This is one of the quote easier unquote to comprehend, I think, because we're not getting into a whole lot of theory about this, and things that we kind of look at, can see, reach out and look at. I won't say reach out and touch, because we can modify, watch, see the results of some of the tools that we're going to look at here. And the topic, maintaining the network infrastructure, we're going to monitor network devices, configure network devices, manage network devices, and then we have device maintenance. So the monitoring tools that we use, SNMP, which we've seen the term a couple of times before, industry standard specified by the Internet Engineering Task Force, used as part of the network management. Monitor devices for conditions that warrant administrative attention. These are, and we'll look at a couple of the monitoring tools, a couple of results of, and then look at one of the monitoring tools. I started it a little while ago, so hopefully it'll have some information in it. NetFlow, can't show you that one. Cisco technology, I don't have it. It monitors displays the statistics about packets flowing through the devices on the network. So it actually shows you flow. It's going to show you, who are the big users, who's using all the bandwidth, what kind of traffic is going to come through. We used to use one of these and to monitor what went in and what went out before we had the application layer firewalls, just to see what kind of traffic was going on. Syslog, we'll take a little closer look at, but basically it's just a piece of software running on a workstation that captures the logging information that we send to it, allow us to do analysis. The Cisco SDM monitor, I want to show you that. It is in the share folder if you want to get a copy of it and play with it. It's a Java application, and it uses a very old version of Java. So if you do want to do it, play with it, you may want to put it on a virtual machine, and the Java is in there. There are also, you may want to poke around a website called firewall.cx, which has got some things, that's the old tools that mostly I don't care about anymore, that kind of give you an idea of how these tools work. So these are going to be the devices that we use to monitor, although the SDM monitor also can be configured. Can be configured to configure, can be used to configure devices. SNMP, Simple Network Management Protocol, and I have to say that slowly because if I don't, I might say SMTP, which is the mail protocol. Network Management Standards for IP-based networks. It has a database structure and then a set of management objects. The MIB, the management information base, and the OID, the object identifiers. It's just and they are a string of numbers, the OIDs, the object identifiers, but they represent different resources, and the information that we get. Implementations typically consist of management application running on one or more NMS network management systems, a computer, and agent applications. Agents are on the devices, executing firmware on various structures that we have on them. So the network management system is a workstation. Actually, it's just the base is the management information base. The MIB and the OIDs, the object identifiers, are on the devices themselves. I'm trying to run as much of my other stuff as I can on a different machine. This is a remote desktop to it. And here we have, and my SNMP is running on a virtual machine, so let's see if it will actually start for me. Let me get onto it. And it's monitoring a couple of different things, and you may or may not, you may have done these things before. This is an add a probe here. You try to get rid of these things. These guys won't go away. This is PRTG, Pressler, Praessler, I think is the way you spell it. You can get your own freeware copy of it that you can monitor up to 100, not devices, but 100 with the sample dashboard. So I can get 100 sensors This one I have 57 available, so 43 sensors are being used. The dashboard gives me some information. I got 9 down. I've got stuff that I put in, took out, that added, that were doing things that don't exist anymore. On this machine, there are 3 virtual hard drives that I took off that show up as a problem. Yep, they're a problem because they're not there anymore. Up, pause, unusual, so the different sensors that are available, and alarms. When something goes out of character, out of sync, we're going to get alarms for these things. When I go back to my devices here, and it's a local probe that goes out here. It's looking at the disk free space, 55% of the local probe's the local machine. System health, Intel Pro, 100 connections. I get a red on it. My NIC on my virtual machine kind of gets. Network discovery, the internet, HTTP to get there, 258 milliseconds, and it just went down to 167. The gateway, the default gateway, 192.168.1.1, and DNS, we have, like instantaneous response. The DNS, 2 milliseconds. I use OpenDNS for my DNS resolution. 127.0.0.1, which is obviously the local machine, 26% of the CPU load, 55% of the disk is free, memory 49% is in use, page file usage, and on down the line. Just give an idea of different things that we can watch. The one down here at the bottom, the 192.168.1.80 is looking at a Cisco router that's running in a piece of software called GNS. Just look for PRAS. Let me see if I can. I'll see if I can get a link and I'll put it in there. PRASSLER is the I think is the name of the company to get that. Yeah, PAESSLER. Or actually just search the internet for PRTG, and that's what this the Passler PRTG Systems Administrator. So just search for PRTG and you should be able to get a copy. If you got to register with them, and they're going to try to sell you one, obviously, but they do have the free version still, and you get a lot of things available. This is well, actually you can add Windows the Windows monitoring to it also. But down here at the bottom, the router, the ping time to the router, 10 milliseconds. The certificates, and I think it's interesting that I have one that says, oh no, they're no good, and one says, well, they're kind of okay, weak protocols, but they're still there. The CPU load 1%, which is probably about right. The traffic on the Ethernet interface, the only traffic is this traffic, because that router is not doing anything. It's also running on this particular physical machine. The system health, so a number of things that we can monitor. Uptime, so I said I did start it a little earlier so that we could get a little traffic in here. And what you can see on them is the history of some of these things. If I go, where is my history? Here I got 2 days worth of information. We can look at different things. 30 days, 365 days, and my 365 days are going to have a lot of downtime on them because I only start these things for classes. So you can see that when they come up and they go down, and the different things that we're looking at, ping times, CPU load, that goes on and on and on around these things. We should also be able to, I think, go into this and see the live graph, 2 hours, what goes on for the for this particular one, and I forgot what I clicked on here. Oh, the HTTP sensor. So the live graph, 2 hours, 2 days, 30 days, 365 days. So you can maintain, monitor, see what's going on for up to a year's worth of information. SNMP, kind of a handy thing to have, and things like it. There are a lot of, I won't say a lot of, there are a number of those kinds of tools that are available. Some of them obviously are paid. Some of them, if you just want to try out, available in the trial version. Some of them really are very good, obviously. Some of them, yeah, over there. So 3 major revisions of SNMP, 1, 2, and 3. That 1 was the original. It's not used anymore. When we say SNMP today, we're typically talking about SNMP version 2. The version 3 actually has security in it. So it obviously is the one that we want to use if it's available. It's like everything else that we have in these things. We say, oh yeah, we have this great thing and we need to use it. But we can only use the things that are available to us. I thought I had an SNMP capture. See it. I do have one somewhere. I just don't know where it is right now. I'll get it and show you what it looks like after we take a break here, or get to the end, whichever comes first. 3 major revisions. The Cisco supports 1 and 2C. 2C is the current 2 version. In the standard MIB management information object, along with the special enterprise MIBs, 1 initially developed and it's gone away. Start SNMP on the packet tracer. Yeah, you can get it on the PC desktop. Exactly. Packet tracer is a pretty good piece of software. If you get it, play with it. Gives you a lot of options in order to do things. Introduced to meet the need for better security because of SNMP v2. The SNMP v2, they talk about, oh yeah, it's got a security on it. It's got a plain text, clear text, and that's one of the things I wanted you to see. Community string, and the default for the read-only community string is public, and the read-write community string is private. So, you know, not a whole lot of, I guess, security with those, and I'm poking around trying to see if I have those scans someplace obvious. Captures. Well, I guess I don't have an SNMP scan. TCP, virtual PC. Yeah, I'll keep looking so you can see what they look like. The OID, well, that's kind of interesting. Oh yeah, okay. The OID, this is, you know, this is not anything that you actually have to know, but what this is trying to show is that we start with the root, just like all the other things. We go down to ISO. It is a string of numbers that represent a resource. Here we have, it would look like 1.3.6.1. So SNMP 1.3.6.1.4, and don't ask me what they are, y'all. This one is a DPS alarm control. And this one says that it's going to get to the internet. 1.3.6.1 is an internet type of device. And then 0.1, and then we go to 0.4 is private enterprise, and then the 26282, we get down to that it is an alarm code. So each of these numbers represents some sort of a device. No, I messed that up. So another way to look at these things, we have the root, the ISO, the organization, DoD, internet, management, experimental, private, directory, different things. The whole purpose of this, showing this is, yeah, it's a string of characters, and those string of characters represent a device of some sort. This is the ASA, and this looks like it is probably, this is a PRTG. You can configure your own dashboard. This would be the monitoring dashboard, PRTG, to do it. It monitors. Obviously, you saw what it has, what we have with these things. This is one called MRTG, the open source variant of PRTG. Actually, PRTG is the commercial variant of MRTG. We used to run this pretty regularly, not pretty regularly, daily, hourly, every minute, to monitor our classrooms to see if anything got out of kilter on the data transfers. And this is just one that was monitoring the bandwidth that was used, that would be used on these devices. And this is pretty much what ours would have looked like. We monitored some outside interfaces, we monitored the classroom interfaces to see what kind of traffic was going on. And if you get something out of the ordinary, you're going to go do a little bit more investigation of what's going on. If you're monitoring and at 2 o'clock in the morning, for some reason your bandwidth pops up to 100%, then you kind of get curious about what's going on with these things. Our headquarters activity kind of had something like that, they had on the afternoon, I guess the webmaster wanted to update the website. So, and he worked from home. So they punched a hole in the firewall, let the webmaster in a port 21 FTP port, and for some unknown reason made it an anonymous access. I guess it was just easier than anybody could get in. They didn't intend to leave it open that long, except they forgot about it. So these scans that go on the internet all of the time, constantly, found this port 21 open. So somebody from Germany actually uploaded a movie to share on that device. Because, hey, he had FTP, anonymous access. Oh, you guys come here, FTP, anonymous access, download your movie. We found that by doing this kind of monitoring. 2 o'clock in the morning, full pipe outbound from the server. So, that's not exactly right. Their explanation was, oh, it's the day before finals and everybody's studying. Well, that wouldn't have happened anyway, but I doubt those things. NetFlow Traffic Analyzer, and these things always sound really good, and they are. And some of this is not outrageous, I guess, but if you go down here, the NetFlow Analyzer, the key features, bandwidth monitoring, network traffic analysis, performance analysis dashboard, CB, quality assurance policy optimization, customizable network traffic reports, in-bar advanced application recognition, starts at $18.75. So some of this stuff is expensive, and if you look at PRTG, if you look at the pricing on it for commercial use, it gets a little pricey. All of these tools get a little pricey, but they're things that you only got to buy one time, and what are they going to save you? How much are they going to save you that we look at these things? So it captures data from the ingress, the incoming, and the egress, the outgoing packets. Fancy words that we use are not really fancy, but ingress and egress are the terms that you'll use a lot. Ingress coming in and egress going out. Collect statistics from the packets such as the IP to IP, MPLS, multi-protocol layers, layer system, not layer, well, MPLS, frame relay terminated packets, ATM terminated packets. So it's watching the flow of data across the network, kind of like the image down here shows. We have traffic, the NetFlow router goes through the router, watches the flow that goes on. The egress gathers statistics for all of the egress, the outgoing packets, and then the MPLS for the multi-protocol label system. MPLS, the label system to IP packets. It's another one of those shims that is configured to make networking within a cloud with usually an ISP to make the data flow much faster. It puts a shim or a label before the IP address so that the devices don't have to read as deep into the packet. One of the things that's made our networks faster. This is a dashboard for it, and then down below what the infrastructure might be like or might look like if you were using one of these things. But we get a lot of information here. It's top devices by speed, the addresses of them, the top devices by volume, the top interfaces by speed, on down the line. So what do we want to monitor, and what do we want to put on the dashboard? The dashboard really is, you can get to all of these things, but what you want to put on the dashboard is the things that are going to show up pretty quickly. Syslog, and we looked at this a little bit. By default, the Cisco devices send message systems and debug to the local logging operation. So it doesn't send those things to us. And it says that my syslog server is already running. There it is. So we can leave it on the router. Not a whole lot of logging can be held there. Plus the fact that we can't really do analysis on that information. We can manually configure the logging process to allow the messages to be sent to different destinations, the different IP address for these things. So the destination for the messages can be a syslog server. Syslog is a piece of software that's running someplace, and this is Kiwi syslog server. It's a free version if you want to get it. And that's another one. Search for Kiwi syslog server. They'll try to sell it to you. They said, oh, you got to update. You need to update it. There's been changes. Well, the updated went to the pay version, so I had to go back and get the free one again in order to keep these things running. We can filter on what we want to display on them. The way that we would configure, let me go back to this. I said all this stuff is running over here on this remote device. I have this structure here. This thing actually to the cloud connects to my network. This is GNS, and I don't know what it stands for, it's just GNS, that runs the IOSs of the devices. So we can use it to, if you don't want to use a packet tracer, for instance, you can get GNS and it actually will run the IOSs. You have to get your own copies of the IOSs, but there's a link on the blog page to get a bunch of them. I'm going to change settings. I want to make this a little bigger so that we can see it. Appearance, and we'll change the font. Now let's try 16. So hopefully this can be seen. What I want to do here is to do syslog, and it's logging, and then it says logging, and then a whole bunch of places, console buffer, host name, IP address of the logging host. So the IP address of the logging host is going to be 192.168.1.27. And then the question marks here, we got a carriage return. SDM demo. Okay, so let's see if it will do that for me. Trap. Set the so we can do. Let's see. This was what syslog trap, right? Syslog. What we can also do. No, it's logging. Trap. And the trap, we've looked at the levels. What level do I want to set on this thing? Alerts, what kind of severity levels do I want on it? So we have critical debugging with 7 and the same thing that that are in that table that we had. So let's say that we want to do everything just out of curiosity, and we're probably not going to get anything. 7 and then the carriage return. If I do a Control Z, then eventually it should tell me that. Let's now talk about logging synchronous, and I think it's already said on this. Logging. One of the things that Mike was talking about the other day. What it does, logging is on NCA. RUS. That's the right command, isn't it? Oh, it's got to be in config mode though. That works a lot better, doesn't it? It's another one that did the tab key. You should say, oh yeah, there's something going on. I thought I was still in. Logging, and let's see what are the options here. Logging, source, and source trap. Logging synchronous. Anyway, translating synchronous, invalid input. That's the right command, isn't it, Mike? That we did. What it does is, yeah, it's the switch. It should be on all of them. It's just not taking it on this one. What that command does. The no IP domain lookup doesn't try to resolve them, and you see the translating synchronous here, and it didn't do it very long. But sometimes you're working on these things, and you save one, and you start typing your next command, and it breaks it in the middle. The log information, the configure from console comes up and breaks the line. What logging synchronous does is keeps everything intact on a single line when we do those. If you use it, and it obviously isn't working for me, so we'll just say that's what that one does, and this one is. I'm also not getting in it. Yeah. Oh, yeah, that's right. Line con 0. Line con 0. Line con 0 config line, and now logging synchronous will do that because I'm at the console. That's why it's line con 0 to do those things, so that we can do those things for it. And I'm trying to make something come up, and I'm not getting anything on it. Yeah, I did too. So we got two giant commands over here because I local 7, I get a notice and an info that says that configured from console, and that I started logging start stop, that I started logging from the syslog server. So whatever happens on the machine, whatever level we want, we can configure for syslog, and the logging command, and then the logging synchronous, which yeah, I should have remembered that was line con 0. And again, if you want to play with the iOS's, GNS3 is the device to do that with. Packet tracer should be sufficient for anything that you want to do. Can filter what goes on it, the messages that we need for the syslog server, and the chart. Again, this is the second time it's shown up in the presentations, and I haven't really gotten any feedback. People said, "Oh yeah, I got to know this," but it's kind of handy. I think that you have a little bit of at least a basic knowledge of what these things are, what they do, and the emergency alert critical sort of things. Those are the ones that we really need to know about. The next device, and we have this pretty thing here, a view that contains the current snapshot. I'm going to go back here because I have SDM running on this virtual machine. No, I didn't want to do that. I just want you to let me log on. Now, let's see. What did I do to myself? So I'll try to go to full screen on that. What it does, and it is, here we go, it's connected to that router just to have something to look at. We have the monitor ability of it up here. Get that out of the way. The monitor, we can monitor what goes on. Let's see, maybe you can still see it, see the hole now, because these headers get in the way up here. We have monitor, the ability to monitor it, monitor what goes on, and we can also configure. So we can look at this thing, the resource status, the memory usage, 45% of the memory is in use. And down here, if we had a firewall, the firewall attempts, the VPN status, logging, what goes on, total entries in the logging, the interface status itself, and it'll take it a few seconds here to refresh and to get some information, maybe get some information in here, but we should see down here the packets, the number of packets that are going on, the bandwidth usage that goes on with it, and packets here. We have packets input, packets output, bandwidth usage, or what are being shown here. We had a firewall configured, the firewall status, VPN status, traffic status, NAC status, network access control status, the logging, and the IPS, the intrusion prevention system status. I had a lot of stuff running on this virtual machine, so that it is SDM. Let's see if we can turn some of this stuff off and maybe make this one have a little bit more information. Yeah, it's still not going to get there, is it? This should have a chart in here. It would have a chart in here for the bandwidth usage that we have on this thing. If we want to use it for configuration, we can do that. We can configure the interfaces. And again, I probably don't have enough memory on the virtual machine for all the stuff that's running on it. Configure the firewall, the VPN, NAT, and this device already has NAT configured on it, but we could, if it didn't, launch the selected task. And it's pretty straightforward. You don't have to type all that stuff in. Fast Ethernet, what's on my outside interface? Fast Ethernet 00. Look at the details of it. Maybe. I think it's really being a uncooperative. So anyway, this is the outside interface. This is the inside IP address. This is the access control list. It's designated. It's already configured to NAT. That's why I can't select this down here. If I could select it, we'd go on and it'd write all the commands for us to do those configurations. So we have the, do I really want to come, yeah, intrusion prevention system that we could configure to do these things. Just looking to see what else is running on this machine. You'd think that it wouldn't be that big of a deal, but it's just not, the video is not really happy with me right now. The whole thing's not real happy with me right now. The interfaces again. So it can be used to monitor as well as to configure the devices. What it will also show you when you want to save something, it'll show you the commands that it's going to put into the configuration file. So you can check and say, yeah, this one doesn't look exactly right. Where that really is a big advantage is if you configure a firewall, it probably puts somewhere around 150 lines in for a firewall configuration. So we can go through the GUI and set up the firewall. Cisco's really big on command line. They're getting more and more and more toward the graphical interfaces that we use these things. So the SDM monitor, a view that contains a current snapshot about the router, view the messages in the router log events. Monitor mode examines the router log. Monitor mode, firewall statistics. Logging's got to be enabled for that. Logging is enabled by default by the SDM, but the default settings can be modified. Additional tasks, router properties, you can configure, and we'll look at, because additional tasks is where a lot of the really cool stuff is that I didn't look at down here, but it's actually in the configure. Maybe we'll look at the additional tasks. Maybe we won't. I think it's not going to play anymore. I'll bring it over here, see if it will sort itself out on the other monitor. It's just not happy at all. What happens to me sometimes with this is my remote session doesn't it got a lot of stuff running on that, Nick. The router is, the virtual machine is, the physical machine is, the remote connection is, so it may be getting confused. I don't know. So we have these things. The monitoring the information, the step-by-step, you can look at that one if you're interested in look at those things. Here we go with the logging. We looked at the logging trap. The show logging I didn't look at, but how we do logging, logs messages to the syslog server, that is configured on it, and the trap sets the severity level. The logging trap does that. This is one of those, a 5-minute lab, so I want to keep going on these things, and then we'll save labs till the end of the lecture here. Device configuration themselves, there are a couple of ways we can do it. Auto install here looks really cool, and auto install is really cool. Setup mode we looked at a little bit earlier. We go through the setup basic configuration. We put an IP address on the monitoring interface, set the secret password, set the line VTY04 password, the telnet password, set the enable password, and we did the IP address for the VLAN. We named it. Some basic configurations on the setup. Auto install allows you to use the devices that you've configured, DHCP servers, TFTP servers, DNS servers, to automatically install and configure a device. So provides an automatic process for configuring the device. Sounds really great. And it is really great, except it takes a lot of work, like all of these automatic things. It takes a lot of work to get the configuration done so that it will work for you. It allows you to automatically load a device configuration file from a remote location. That means, let's say that you're in, we'll do Dallas since most of you are there. You're in Dallas, and you need to put a new router in Los Angeles, and they say you can't go there. Well, you already know you can't get to it because these things come with nothing configured on them. So you can't telnet to it and configure it or add the configuration to it. What this allows to happen is you turn the router on. Somebody at the site has to be there to plug it into the wall, plug it into the network, turn it on, and then it'll automatically get its configuration files to do that. Setup down here, interactive, we did that one. Setup was the startup one. You can, if you want to play with it and it doesn't start and it doesn't go into the configuration mode, you can just go to the command prompt, the command line, get into the config mode and type setup, and it'll take you right into those things. The prerequisites for the Cisco auto install: no configuration file in NVRAM, non-volatile RAM. Configuration files that you want to load to the device using the auto install got to be on a TFTP server. It's connected to the network. In most cases, more than one file is going to be there because we may be doing more than one device. Somebody at the remote site to connect the device to the network, as well as to plug it in, obviously, and turn it on. Ensure that you have network connectivity to get from one to the other. You got to be able to get to a DHCP server. Okay, we got to get a DHCP server. Now we're going to need relay agents for these things. DHCP, broadcast protocol. DHCP is available, and the network can provide the IP addresses to the networking devices. This is, and I think this one I got from Cisco, when we're going to do this. Router A down here is the new router. Sends a DHCP request to its attached Ethernet 0 interface. Let me get this pin going and we'll do some maybe drawing here what's going on with this thing. Now let's see, let's make it a little bit smaller and use a nice pink. So A, we go out here. So A sends a request to the Ethernet 0 interface, a DHCP request. So DHCP request already, our DHCP servers over here, we're going to have a relay because broadcast won't go there. So the relay sends the information to the DHCP server. Router B, the staging server, forwards a request to router D is running DHCP. The DHCP server sends a reply back to router A. So it comes back through the relay agent to router A. The reply contains a temporary IP address. So we're going to get an IP address, but it's going to be a temporary, not the one that it's going to use permanently when we do this thing. Router A and the IP address of the TFTP server, one of the options that we have in here. So we have the TFTP IP. We need that so that we can get the configuration information. Router A sends a request for the network configuration file to the TFTP server. So we go to the TFTP server for the config file. So send it to the TFTP server. Router sends to the TFTP server using the address in step 3. The network configuration file is downloaded from the TFTP server. So now we have a config file. Config file. I spelled that very poorly, didn't I? Config file. The network configuration file downloaded from TFTP does not contain an IP address to hostname mapping for router A's new IP address. So router A sends out a DNS request forwarded by router B to acquire its new host name. The DNS server over here, the DNS server, router C, resolves the IP address of the new router and sends it its host name, router 1. So now it's finally got its name, router 1. And sends the data to router A. Uses its host name to send a unicast message. Again, we're going back to the TFTP server to get its specific for its host configuration file for router 1. So this is a general configuration file to get it, and now we get our real configuration file. So the real config file to do these things. The router 1 config file is loaded as the running configuration file for router A, and you notice the running configuration file, if we have a power failure, it's gone. It then needs to be saved at some point into the startup. So we need to save the running to the start. Copy run start when we do those things. The router A releases its least DHCP address because it's going to have an IP address in the configuration file that it gets. So yes, it is a great way to do it, but it also requires some configurations to do these things. Prerequisites for setup mode, and this is one that I had the question way too early in, include a terminal that's connected to the console port of the device. On the back of a router, you're going to have a couple of different ports. One of them, we're going to have gigabit or fast Ethernet ports, which are obviously going to connect to NICs. For management, we're going to have the console port, which is for local management to plug in from the serial port of our devices. There's also going to be an aux port. The aux port is designed for out-of-band management. Modem. For instance, that same router that you now have configured in Los Angeles, something happens. You can't get to it. You were configuring it, I did this once, configuring it remotely, and you changed the IP address of the WAN interface, and now you can't connect to it. The way around that is out-of-band management, and that's what the aux port is for. You could have a modem connected to it, and then you could connect to that modem, do your configurations, get back online to do those things. So we'll need a terminal, a connector to the console port because it's going to be local. The interfaces that we want to configure, nothing magic in this list here, and then the routing protocols that we want to enable. So, you know, basically the startup things that we want on this router, the interfaces, the IP addresses that we want. You can configure a router for a DHCP address if you'd like. Do you want to do that? In most cases, I think the answer is probably not. They're usually going to be static addresses, and that's what the interfaces and the addresses are all about. And then the routing protocols. Are we using RIP, EIGRP, OSPF? What interfaces are we using with these devices? The initial configuration, to configure the global parameters, configure terminal connect to the router with a remote terminal. And I'll go back to packet tracer just so, because I click on the CLI. There is no CLI on the devices themselves. Use a hostname command to configure the name of the router, enable secret password. One of the reasons that you do need the enable secret password, let's get a couple of devices in here just to do the connectivity, to see what we could do with these things. Now let's bring a router up here. No, it doesn't matter what it is. Bring a router up here. We want to connect it in packet tracer. The blue one here is the console port. It connects to the RS-232 port to the console port. You notice we got the console port and the aux port. Now to connect to it, we have to have a terminal emulation software. You do the exams unless they've changed it. When you do the configs, you're going to go through this process. You're going to connect through a console. The defaults, 9600 port, the bits per second, 9600 bits per second, 8 data bits, no parity, 1 stop bit, and no flow control on this thing. When you get here, we're now on to the router, and it says, we want to go through the initial dialog configuration. I'll say no. Enable config T, and the things that we wanted to do was what? We wanted to do the configure terminal, config T, host name, demo2, so it immediately changes the name. Enable secret, I use that just so that I don't mess it up too many times. The enable secret, and then the no IP domain, IP, yeah, DOMAIN, no, yeah, dash, and see no domain name, no IP domain lookup, so that it doesn't, when I make my typos, it doesn't try to resolve it to an IP address to do an FQDN lookup. And then config P, now that I've had some help on getting there, line con 0 logging synchronous, and the logging synchronous just helps you out in the you're getting disturbed as you're trying to configure these things. If it happens and you start getting things from the console coming back to you, just keep typing. It should allow you to keep going with these things. So the basic, the show where you show running config file to see the configuration, things that you've done multiple times now, and then to enable these things. Then another little short lab set, the discovery protocols. And we've talked about CDP and LLDP, the Cisco Discovery Protocol, Layer 2 data link layer. On all of the Cisco devices, CDP, Cisco Discovery, Cisco Proprietary, it's enabled by default. You can turn it off on the entire device, and I think it's no CDP run. Actually, we can figure that one out for the device. It's no CDP run on one and no CDP enable on the other one. And I think you enable it on the device, on the interfaces, and that you do the run on the device itself. So we can, let me see if I can get something here. It's got some devices. We go back to this. I guess this access control, this one had several devices in it. Well, this one's got a couple of devices in it. It's got a switch and a router. So if we want to show CDP neighbors, yeah, it's connected to a switch and a switch, two 2960 switches. If I want to turn it off, yeah, config T, no CDP, yeah, no runner or enable, no CDP, let's try enable, no CDP, now let's do no CDP run. Yeah, that's what I said, no CDP run on the device and enable on the interfaces. Let's show IP interface brief because I've forgotten what we have. And we have gig 00, so let's go to config T and do interface gig 0/0, and we'll do CDP enable. And now let's see, shows CDP neighbors. CDP is not enabled, so I can turn it off on the entire device with the no CDP run, or I can do it on the individual interfaces with the no CDP enable or CDP enable, turn it off and turn it on. But if you do the no run, it doesn't run it at all on the device. Only Cisco devices, Cisco proprietary obviously. LLDP, Link Layer Discovery Protocol, is the one that is the standard, the IEEE 802.1 AB standard. Non-Cisco devices, interoperability between devices. So if we have a multi-vendor environment, we need to probably use LLDP instead of CDP. CDP, Cisco proprietary, worked great on those. Licensing, and this is again not again, but this particular lesson chapter is kind of a hodgepodge catch-all for a bunch of things that show up here and there. Not very long ago, not in the beginning, but a few years ago, when we bought, or still when you buy a router, you get an iOS with it. The iOS supports certain things. Up here at the top, IP-based, base plus data, base plus voice, security and data and security, voice and security, voice and security, voice security and data. The blue security should be data, voice and data. If we wanted to upgrade the iOS, we'd go to Cisco, buy the new iOS, download the binary file, and copy it from a TFTP server into flash memory. And we would update the operating system. When you copied it, it deletes the old one and puts the new one in. So it's going to be the one that you boot to. One of the things that you got caught in this trap one time, you have to be sure of is that it's going to fit, that there's enough memory for the new iOS. If it doesn't fit, and I got into this and I said, oh, this looks like a good one, we're going to put it on one of the student routers. And start copying it up and doing good, and all of a sudden it quit. It's out of memory. What do? I had saved a copy of the old iOS before I started, fearing that something like that might happen. So as long as the router's running, the old operating system is in memory. It loads the whole thing in memory. Unlike the Windows machines today, it's too much there to do it. DOS used to do that. If any of you ever used DOS, you could actually delete the DOS directory and it'd keep running for a while until it needed an external command. Same thing happens here with Cisco. It loads the operating system into memory. It has to fit. So what I did, I just deleted the one that I was trying to install and then loaded the other one back in and it worked. That is the old way to do it. The one on the right works pretty much the way Windows does today. You get an operating system that has all the features in it. And what runs is the features that you license. Just like in Microsoft, you get a DVD to install this or an iOS to install it, and you put in your license key. And whatever the license key supports is the version you're going to get, whether it's home or enterprise or student or academic or whatever we have for these things. So Cisco has gone to that type of licensing, and one of the images here and one of the slides here in a minute is going to be how you do that, how you would upgrade these things. So in the newer versions, Cisco's begun using the iOS packaging model, universal image with all of the feature sets. So instead of getting, if we want to upgrade to the IP to the base iOS plus security, we don't have to go get a new binary file. We just go get a new license to license that feature. Feature set includes the base, voice, security, advanced IP feature set. Would produce one universal image with all the features, and then the software download section of Cisco.com checks the user's credentials, and you've got to unlock the features, the feature set using the software activation process defined by Cisco. Manual process, you browse to the Cisco licensing server. We've got an image for that. This is what the steps here, and this one's shown in here so that we're going to need the UDI, the unique device identifications, the serial number, and the PID, not the process ID, maybe the process ID. Yeah, product. We get a product activation key, but to show the license that we have on these things, the unique device identifier is going to be something that we're going to have for these things. So we've got the words here. I told you I like pictures. So what we do is, one, we purchase the product activation key from Cisco. Once we've purchased it, we get the UDI, unique, I said universal, the unique device identifier from the device itself. And that's what this is here, the UDI, the unique device identifier, serial number, and I think that is product ID because it's a Cisco 2911K9, and then the serial number. When you put the two together, it's a unique device identifier. So then after we get it, we go to the UDI and the product activation key are entered into Cisco's licensing portal at cisco.com. Once we have that, we get a license. A license file is sent via email, can also be downloaded at the time. So we store it someplace, and then you install the license onto the device that you have just licensed. And I think that we go here, the command line, license, install, and then wherever it is, this is the command that you would use at the command line to do these things. So the step-by-step kind of updated process for Cisco to do the activation. I thought I had an SNMP. I just wanted to show this, that the object identifier over here, the series of numbers, the community string, the password here, plain text. The port here, the source port, destination port 161. SNMP uses ports 161 and 162. We've talked a little bit about some of these already. The console logging is the default. The messages come to the console. Terminal would be like a telnet. We have a terminal connection. And if the VTY terminal, virtual terminal connection, it's not on by default. You have to turn it on in order to see it with the remote connection. Buffered logging, buffer in RAM, fixed size, so that you don't fill the RAM up with logging information. Syslog we've looked at configuring it, and SNMP trap logging allows the router to use SNMP traps to send log messages to the SNMP server. So similar processes, either we can keep the logs on the device or we can send them off of the device. Time zone, I think when we looked at the clock at the NTP, we looked at some time zone stuff. So use the clock time zone global configuration mode in order to do that. What this one's talking about, in the Unified Intelligence Center, a central location for collecting information, it's going to have multiple time zones. It's going to have the time zone for the server that it's running on, for the data source if it doesn't come from the same time zone, for the report, and for the user. All of this may be in different time zones, and the objective here is to bring everything into a common time so that we can have that. The multiple time zones have to be interpreted. We use that, the clock time zone command, and you can set the time zones for it there. A loopback interface, and the loopback interface can mean a couple of things. One is a virtual interface that we have here. The other is a loopback connection for doing troubleshooting. The virtual interface itself is just a matter of going in and configuring interface LO whatever, loopback this or loopback that. I can't get into this one because I already messed it up for the next one, but if we go into this router here and config T and do interface LO1, it automatically creates a loopback interface for us. Advantage to the loopback interface is that they don't ever go down. No interface LO1. I want to get rid of that because I don't really want it on here. They don't ever go down. They can be used for configuration for connections. In some of the routing protocols, the election of the different properties are going to be based upon the highest IP address of a loopback interface. So they don't go down, used for configuration. They're used for configuration because they don't change. We put an IP address on it, it stays there. That interface never goes down. So the loopback interface is commonly used for management packets as a primary port for the management practices. Any packet is transmitted over a loopback interface, immediately received by this interface, emulates a physical interface, used for performance analysis testing, can act as a termination address for routing protocol sessions. And I think BGP actually recommends that you use for the destination IP for those that you use a loopback, because again, they don't go down. They stay up. They're not like that. They do emulate physical interfaces, but unlike a physical interface, they don't go down. Types of loopbacks, and these are the troubleshooting ones. We have the local loopback, which just checks the NIC itself, and these are all on T1 channels. T1, I said NIC. Loopback for the T1 channel. The network line loops the data back towards the network before the T1 frame. The payload loops a payload back, and these are just different degrees of checking the connectivity on a network. If you are working for an ISP, you probably will work for these things. If you're working for a company, you're probably not going to get into these, because you get this sort of check from the ISP. So, you know, we have a problem here. We're not getting any connectivity. We're not getting anywhere. So they'll say, oh, we'll check this out for you. The little image down there is a loopback connector. That's a fiber loopback connector. The remote line in-band 5-bit in-band pattern to the end, requesting it to enter into the network loopback, and then the loopback remote line band command allows the enable to loop back to the T1 channels. It's a troubleshooting method for T1. Backup and restore, I think we've visited this a little bit. Use a TFTP server and FTP terminal emulator program. The easiest way is copy whatever to TFTP. Mark says he's not getting the audio and video. Oh. Oh, thank you. I guess that you wouldn't be. Sorry about it. Let's go back to this one then. The loopback interface, the image is that we would have there. You saw me make that one. It's a virtual interface used for configuration. They don't go down, and that's the advantage of them. Commonly used as a primary port for the management packets. Packet is transmitted over it, immediately received, so we have those. Interface emulates the physical interface used for performance analysis. We make the loopback interface LO1. You saw that even when you couldn't hear it. It becomes a virtual interface on the device. Emulates a physical interface. When we get into the routing protocols next time, they elect different members to do different functions. The highest IP address on the loopback interface is the one that's going to win. So we can dictate what happens there with those. Physical interfaces may go down. Virtual interfaces don't go down. And I think BGP recommends that you use the virtual interface to do these things. This is a troubleshooting loopback. We have loopback connectors. You can put them on a NIC on a computer, and it checks the NIC for you. What this one does is checks the different levels of what we do to check the T1 line, and try to have some images here to see what they are. The local loop to the router, the local loops the router output back towards the router at the T1 frame and sends the signal out towards the network. Loopback local command allows you to enable the local loopback on the T1 channel. The network line before the T1 frame allows you to enable the network line loopback on the T1 channel. We'll check in a little bit more of the process. And then we'll put a payload on it. When you put payloads on these devices, you can get different sorts of reactions to them. We had when we were first trying to learn how to use the T1, the twisted pair, everybody had a different idea about what to do it, and as it winds up, you just make it the way you're supposed to. But do different things, and had it configured wrong, the line was configured wrong. We could have connectivity to the server that this improperly made wire was connected to, but when we loaded it, nothing happened. We didn't get any data transfer. So that's why you check the line, then you check the payload, and then you do the remote line in-band, sends the signal down to the remote to try to check these things. So different capabilities to check T1 lines. And unless you're probably working at an ISP, you're not going to do a whole lot of that. Back to the backup and restore configuration. Different methods to do that: TFTP, FTP, terminal emulation program. TFTP is what you're typically going to use to make backup copies of your configuration files, as well as the iOSs, as well as flash memory. And I would recommend that when you're doing these, when you get running servers or routers, that you do make copies of your flash, because just like it's hard to get a DVD, if you've got Windows, they don't get DVDs now. You get these restore partitions, and if something happens to the hard drive, the restore partition's an issue. Same thing happens here. They're not going to really give you another copy of it. You need to make your own copies of these things. And it's just a matter of copy whatever. Copy run TFTP, copy start TFTP, have a TFTP server software running on the workstation that the IP address that you're copying it to. You can get those for free. A number of them are available on the internet. So we're going to keep the configuration files there. And again, configuration files, what going to be the advantage of that is that if we get into a situation that the router died and we get a new router, instead of going in and putting in our 400 or 500 lines of config and we'll forget one or make a couple of typos, you just simply copy the one that you had up to the server. So you copy, then you would copy TFTP to start or copy TFTP to run to get those things in there. Another little lab set here. The iOS upgrades, we talk about it and then we come back to here. Shipped with images. Each image contains the iOS software. After some time, you may want to load a different image, have different capabilities on the routers. iOS, the latest release, you may want to uniformly use the same iOS release for all of the routers. Each image contains different sets of features. You need to select the appropriate image, and yes, we do, and we may want them all to have the same feature. You may want them to have different features, but we can't upgrade these things. Recovery, if the iOS gets corrupted and you go into a ROM-MON mode, read-only memory monitor, read-only monitor mode. If you ever see ROM-MON, say, I've got a problem. The iOS gets corrupted. They got a set of things here, the list and all that other stuff. If it ever happens to you, and I had it happen with the students one time, they wanted to delete their configuration file, but instead of doing that, they deleted the operating system. So we've got a router with no operating system. go to Cisco, get the step-by-step, IP by IP, connection by connection instructions, and do exactly what it says. The iOS here, there are a couple of things here. Status of RNX, read and execute, indicates it's a valid image, and this is one that an image may be marked for deletion, but it's still there. If the execute's not present, the image is probably going to be corrupted. And Cisco and Linux stuff, they're all based on Unix, are going to look very similar. And down here, the D is present. The image has been marked for deletion but has not been deleted yet. Kind of like a database, you mark a database entry for deletion, and then in the old system in DBase, you had to run the pack command to actually make it go away. A similar thing happens to get these things deleted. Recover the iOS software image, boot from a TFTP server, download the image via TFTP. You got to connect it up. You have to you've got the basic configuration files, and we'll look at some of that when we're going to do the password recovery here in just a second. That you can put an IP address on it, and then you can copy the new image from the TFTP server to it. It says download the image via the console, via the X modem, without X modem, TFTP. The TFTP process should work to do that. If you have booted it from a TFTP server, and you can boot it from a TFTP server, the configuration register, which we're going to modify again here in just in a couple of slides to recover a password, specifies where all this stuff is. Do you have a startup config file? Where is your iOS loaded? It does not have to be stored on the device itself. You may store your images, standard image, store it on a TFTP server, and all of your devices would then load the same image when we would do that. So verify the image after we get the new image, the MD5 hash verify, compare the two. You can obviously run the hash yourself and compare it to the hash that came with it, and this is the way to make the file system do the comparison for you. The password recovery, the enable secret password, is we've configured that thing and it's encrypted. It's actually hashed with an MD5 hash, replaced with a new password, and you get into a situation that you don't know what it is. We had a bunch of routers, the classes came back that the images, the labs told them to create a password with your initial and name or something. So you had to know who was using which router in order to do these things. What I want to do is I think this is the wrong one. Go to this one down here. I've messed it up already. So when I go into enable, what's the password? I don't know, and I really don't know. I just put a random string of characters in here for this one. Then we try 3 times and it said bad secrets. I don't know what it is. The first thing we need to do is go in here and show version to find out what our configuration register is right now. It's 2102. What we're going to do is to restart this thing, and then we're going to do a control break. What I've got to do is turn it off, physical, turn it off, if I can find the switch on it, turn it off, turn it back on, and in here, and then do a control break in the middle, and I'm in ROM-MON mode. And again, if you see this one for real, you don't really want it. What we're going to do now is configuration register 0 by 2142. 0 and 0. The X says that it's a hexadecimal number. 2142. And then after that, we're going to reset it. What this should do is to reset, reload it, and when it comes up with that configuration register, it says don't look for a startup config file. So we're in initial configuration, and we'll say no. And if I do enable here, I'm in. If I show start, Yep, I've got a password in here. Haven't a clue what it is. So in this case, instead of copy run start, we're going to copy the startup config to the running config file. Destination file running, yes. And now we're in here, we're in enable mode, and so we can go to config T and do an enable secret. Change it to something that we know. And then we're going to copy run start to overwrite that old password. So after we do that, now we need to set the configuration register back to what it was, the old one, which is config T, and it's config register 02102. When we do that, and now once we have done that, do the Control Z here, configured from the console, and try a reload and see if we've actually done this. And we're going to say yes, it's been modified. The system configuration has been modified. Do we want to change it? The system configuration is the config register, and yeah, we wanted to save it. You have to have physical access for this process to work. Now let's see if we get in here, and the password is secret, so we're back in. That's the way, the quick and dirty, the overview demo, how you do that. It may be a little bit different for each router. This is another thing that Cisco is going to have, but you see the show version to get the configuration register, the proper numbers for it, the proper hexadecimal number. Go into ROM mod mode, control break after you restart the device. You'll get into ROM mod. Use the conf reg configure register 02142. Do a reset to restart the device itself, to restart the device. And then after we get over here, we do the same thing. We copy the start to the run, change the password, save the startup save the running to the startup configuration file, and then change the configuration register back. A lot of steps there, kind of, sort of, but you can recover the password if you can have physical access back to the security of things. If you have physical access, you can do an awful lot of stuff. You can do an awful lot of damage with things. You can lock people out of these things, but of course, if they have physical access, they can get themselves back in. You can get into them, modify things, physical connectivity. The other method here is if it has a USB flash drive on it. What you do is you remove the compact flash, configuration register file, reinsert the compact flash, do the reset, basically the same process that we used before. The configuration register is a 16-bit configuration file to specify, and there are different, obviously, things that it does. Specify what's where. Is the iOS in flash, or is it at a TFTP server? Is there a startup config file in NVRAM? We changed it in the one that we recovered to tell it not to look for a startup configuration file. So we have those. This is kind of there are bigger lists, obviously, than this, but the 2102, load the iOS from flash, and then the configuration from NVRAM. That's the one that we changed it back to. 2100, load the ROM monitor mode. 2101, a mini iOS. 2142, which is what we used to get into it, load the iOS from flash, and don't load the startup config file. There are other documents, obviously, give a more extensive look at what this thing is. The file system itself, the Internet File Systems, the Cisco that we have, includes the endpoint reading and writing of data, the different things. But what the bottom line here is, we can use the show file systems to determine which prefixes are available, which file systems do we have, and then once we have those, we can determine what's where on these systems. So let's see if this works. This just so that we can get from one to the other. So what was it? Show. Can spell show right. Show file systems, and here we have the file systems. We have the flash and NVRAM, and we can use the CD. Let's go CD NVRAM and see if it gets there now. It's LS, and this CD is an unrecognized command because this one's not there. They changed the commands. LS used to be the things that we're using. I don't think that's going to be there either. But we can get around in the systems, in the file system itself, and it's going to tell me which commands I'm supposed to use here in just a second. So the show file systems shows us which we can do or what we can get to. NVRAM, obviously, where the configuration files are stored, and the and flash, where the flash memory is stored. Go back to this thing to show the file systems. Read write flash 0, the size that is in it. So the file systems, I probably it's going to be a show NVRAM. Let's see if that works. No, it's not going to work. I will get that one. We'll probably get it here in a second. So when we have these things, the show file systems command, you can specify the file system or directory that the system uses for the default files. The CD command is supposed to work on these things. And I'm going to probably go crazy on this. CD, and let's try NVRAM colon. Yeah, this is one of those that it's one of the devices that's kind of between, and this thing is not programmed. Some of the devices are not programmed for everything that we have on them. So the CD should work on these to get from one to the other to look at what's going on, and you can see what files are in it with the list command. Ping and the troubleshooting commands that we have, the ping, traceroute, terminal monitor, things that we've kind of looked at before. Ping, but we're going to have the extended ping. If we use the ping of an IP address, then it just goes there. If we use the extended ping, where we would, let's go back up here and just type ping, and you can, and we have to be in the privileged exec mode. Ping, and just enter the protocol IP, the target IP address, and I don't even have a good target IP address. I guess 2.192.168.2.2, 192.168.2.2, and then the repeat count, the default's 5. Let's say that I want it to go for a long time. We won't do a whole lot. We can say 50 or 20 to repeat. The datagram size, and we can change the datagram size if we want. The timeout, we'll leave it at 2 seconds. Any extended commands, we'll say no. Sweep range. So it starts sending the 20 ping packets, the echo request packets. The dot here again says that, yep, it didn't succeed the first time, and again, typically that's what's going to happen. In Cisco devices, ARP is the culprit there, that it has to get the MAC address in order to do that. So normal ping sends 5 of them from one to the other. The extended ping, we can, the ping protocol, the target IP, the address, the repeat count, the things that we saw on it. We can have traceroute has a similar sort of configuration that's available to it. So we can, instead of doing just traceroute, which we could do from the user exec mode, traceroute Same thing, protocol IP, the target IP address 192.168.2.2, just to have it to get someplace to get the source address that we're going to send this from. This is going to be and it has to actually be a real IP address that's on this device, 192.168.2.1. So yeah, we can spoof the address. We have to specify which interface that we want it to come from. Minimum time to live 1, which is going to be the start, and the maximum will go 30 hops on this one. We're not going to go very far because we just go to it, but we have the extended trace route as well as the extended ping. The way you do those is in privilege exec mode. You just type the command. The interrupt here, finally, after you get hung up multiple times on these things, we get to the interrupt, and it says Control-Shift-6. When you use all those three together, it is the interrupt. It's just like the Control-C in DOS or in the command prompt in Windows. Terminal monitor mode allows us to display the messages to the terminal connection. So if you want to be able to see the console messages on a remote terminal, terminal monitor mode allows you to do that. No arguments, it just allows you to do these things. So we did get to the end with time for you to do the labs. We talked about some monitoring tools, SNMP, and we looked at PRTG, what it looks like. NetFlow, couldn't do the demonstration with because it's a Cisco device that monitors the flow across the network. Syslog, we looked at configured syslog on a device. We had the logging to the syslog server, and then the trap to specify what levels that we wanted to look at. The Cisco SDM security device manager can be used for monitoring as well as configuration. NetFlow captures the ingress and the egress. Two features, the AutoInstall and the setup mode. Try to go through show that the AutoInstall is really good, but it takes some considerable configuration, pre-configuration, in order to make it work. A router with no configuration, the first time is going to be going into the script, which we saw. We can get there with the setup. Do we want to enter that mode? And hopefully after you do the lab, you'll say, no, I don't really need to do that. I know how to go into config T and type host name. I know how to type interface, whatever the management interface is going to be, and put an IP address on it. I don't need that help. Discovery protocols, Cisco CDP, Cisco Discovery Protocol, Cisco proprietary LLDP, link layer discovery protocol, is for a multi-vendor environment. And CDP is enabled by default on the Cisco devices, can be turned off on the whole device, the entire device with the no CDP run, and on individual interfaces with the no CDP enabled. If you want to turn it on after you turn it off, CDP enabled to do that. You might say, well, I don't really want it running. If you have the Cisco phones, Cisco VoIP phones, we need that because that's the way they get their configuration information. Copy of the current router configs, part of the overall backup and strategy. TFTP server is a great way to do that. Copy run TFTP, copy flash TFTP, whichever ones we're going to use with that. The system image is going to be there. We can upgrade those. The newer ones, the licensing process, because all of the features are in the one image, and we get whichever features that we have enabled. The configuration register, 16-bit configuration register in NVRAM, specifies where the system's going to look in order to find its flash, its iOS, and where it's going to look, whether it's going to look, and where it's going to look for the startup config file. The file system feature a single interface to all of the systems available on your routing device. So show file systems, and then the CD command is supposed to work on the newer features, and I'll see if I can get that for tomorrow. Right now, we can do some lab